Okay, welcome to the second practical session. Today we have a guest with us. Maybe you want to introduce yourself?
Hi, I'm Elias. I'm one of the OOP TAs. This is my first year as OOP TA, and I've also done ESB before, but like the year before.
And we will, in the next couple of weeks, we will very often have guest lecturers here. This is simply because I'm already 4.5 years in this course, and 5 years is the maximum. So we're searching for support for Julia for the next years, and so we invite some of our TAs that they give a short talk about some of the important topics, and that they can have a feeling on how it is to stand in front of you in a lecture hall, if this is something they want to do in the future.
Okay, so what will we show you today? Of course, first organizational matters. Then Elias will show you about input and files in C++. So some familiar stuff, some new. Then we'll have a recap about destructors, copy constructor, and also dynamic memory. So we will have a short example there, and then we will have a bigger example with a heap array that will, or a heap vector that we'll code on our own.
So we'll basically implement the SCD vector on our own into the S class. So this is really cool, I think.
Yeah, so let's get started with organizational matters. So homework 1, the deadline was today. Yesterday, right? And the grading will be available today. It's not yet, but it will hopefully be later. We already graded it. We took a look at your assignments. And then later, after the lecture, we'll write an announcement, and then you can find your grading of homework 1. Then assignment 1 starts today. We also already have the kickoff video ready. You will be able to see it at 7. Your repositories will be available later. We don't know exactly when yet, but you will have the upstream ready when the kickoff video goes online. Again, as in Introduction to Structured Programming, you will just submit your solution to GitLab, and the last commit before the deadline then counts.
Yeah, and deadline is in 2 weeks, so 2 weeks for assignment 1, and then a couple of days before the Easter break starts. The deadline is, and then we also announce assignment 2.
Okay, so how will be A1 graded? It will give you 18 points. There won't be any assignment interview. Also, there's no coding standard or style guide. But there are some functionality and some specifications you need to follow. And also, your code should be readable. Then you need to pass 50% of the public test cases. I think this was already said in the first lecture, but we'll repeat. So you need to pass at least 5 test cases. Otherwise, you won't get a grade in this course and you will be deregistered. But I think passing 5 public test cases on A1 is more than doable.
Yeah, and otherwise, you cannot continue and you will not receive a grade. Yeah. Okay, I think that was it for the organizational matters. And now we head to our first topic, which is input and files in C++.
Yep, and I'm going to start right off with input in C++. So you should be familiar with stdcout and writing to stdcout, and there is an equivalent for that for reading input, and it's called stdcin. And I hope you can see this here in this short snippet. In order to read input from stdcin, we define a variable that we want to write it into, and then we call cin with those double greater signs, and cin writes the output into the variable that we specified for us. Okay, so stdcin works very similar to scanf in C, and this comes with some problems. Because if the input type, the expected input type is not matched, you might run into some problems. And I'm gonna switch right over to some example code. You can see that's just the code that we had up earlier. So we are reading with cin into this variable, and the variable is of type integer. I'm going to execute this real quick. So
let's see whether our other tutors can also compile as well as we do in the...
what's the file name though? Main.
I just called it main CPP for you.
And let's execute this directly. Yeah. And it's waiting for an input. And if I give 2 as an input and press enter, it works. We get you enter 2 as an output. That's expected. Now, if I rerun this and if I'm like fancy and I write 2 out, it says I entered 0. So it's expected. Like, of course, it crashes if we give the wrong variable type, but it would be nice if it doesn't do that in our programs. So there is a replacement, a better version of this, and it is called std_getLine, and it works roughly like that. So we have getLine, then we specify the input stream, in this case cin, a variable name, string, and the delimiter. And what it does is it reads from cin into the string until a delimiter is found. So maybe as a short specification for anyone who doesn't know what a delimiter is well, we basically tell where it should stop reading. And
so basically, if the delimiter would be a space character, then it would just read the first word until it reached the first space.
Exactly. And you can set this, but you can also let it unset. And if you don't specify a delimiter, it will just be \n per default. Good. We are going to jump back into the coding example and replace getLine with replace reading from stdcin with getLine now. So in order to do that, we will have to make this a string, and we are going to getLine. And of course, we have to specify the stream that we will be reading from. In our case, this is stdcin. And yeah, this should almost work now. The only thing that I didn't do yet is, so getLine is contained in the library string. So I have to include string. Yeah. And of course, finding errors before compiling, of course I have to
so in this case,
add the namespace.
You don't specify the delimiter, so it defaults back to \n.
Exactly. So we just read in the whole line. Okay, and now I can just write 2 as I did earlier, and it will write you enter 2. And I can also write 2.
Did you compile? Yeah.
I think I did. Yeah, I should have. Yeah.
You need to save it. Yeah.
Oh, yeah. Sorry, I'm used to having autosave on. Thanks.
That's my bad then.
Yeah. Entering nothing also won't help. But if I go with 2 now, yeah. it prints 2 in a fancy way. Of course, now if we want to use a number, we have to convert the string to a number later on, but we won't have problems such as the earlier one.
So basically, in assignment 1, you will have to convert a string input, which should contain an integer, to a number, so that it's actually stored in an integer. And this is something we will not discuss today because it's basically we don't know the concepts yet that you need to use there. So we will provide this functionality in assignment 1 as a helper function that you can use. Because I think we will discuss this topic is discussed in the lecture at some point today. Is it? Yeah, they don't listen to us. But yeah, you don't know this yet, so there will be a function provided to convert a string into an integer if this is possible.
Yeah. So let's go back to the slides. Yeah. So that's just the code we had now. And we are going to go to the topic of reading files in C++. So the nice thing is that files work very similarly. Files are streams. That's why we can just specify them as a parameter of getLine, and it will work the same. So the way we do this, we can we can make an if stream object. If this just stands for input file stream object, which is a file that we can read from. And of course, we have to check whether the opening worked correctly. We can do that with the function isOpen, and then we can just use std_getLine to read from it. And another nice thing is that if we have files as ifstream objects, they will just be closed automatically when the variable goes out of scope.
So basically, we don't have to call something like fclose at the end.
Yeah, exactly. That's super neat.
Maybe one question to you. Why is this not possible that the file closes itself when going out of scope?
Because of a destructor?
Yeah, exactly. So due to a destructor, this functionality can be implemented such that when the file object runs out of scope, it automatically closes. So this is really convenient in C++.
Yeah. Okay. There is something that I want to add to std_getLine now, that we can run files, read files, and just short, we can now specify a file as the first parameter of getLine. And what getLine does, an important functionality that we will be relying on later, is getLine returns has a return value, which will be true if it was successful, if it could successfully read a line, or false if it got an end of file, just otherwise false, yeah. And I have to admit this is not technically correct. So it's not technically correct, but it's good enough for now. I will go into the detailed explanation just now, but you're missing some basics. You will understand all of it as soon as you do operator overloading in the lecture. But it's rather straightforward, even without that, to just grasp it basically. So the truth about std_getLine is that std_getLine actually returns the stream back, and there is a conversion operator which converts the stream to a Boolean value, and that's just, as we said, it will be true if the stream is in a good state, and it will be false otherwise. And this is implemented by just like getLine sets 1 bit in this stream object, a failed bit, and if this failed bit is set, we know that the getLine wasn't successful.
So basically, the getLine function takes the file, checks, I can read something, or no, I can't read anything anymore. Okay, in this case, I will make an indicator I couldn't read anything, and I will return false, so that you also know that it was not possible to read something here.
Exactly. But for now, we're just going to stick with this simple explanation. It gives us true if we can still work with it. It gives us false if we can't work with it. That should be fine for now. And I'm going to show you this now. So we are going to throw this code out, and we are going to make a file object. So if input file stream, we're just going to call it file. And did you prepare the folder for me? So
No, I opened already the file.
Oh yeah, I can see
folder,
it. Perfect, perfect. Okay, so there is this file that's called surprise.txt. Contents won't be revealed, and we are going to read from that. And we can already see that we have errors. This is because if input file stream is in another module, and we can include this by fstream, that's the name of the module. And now, yeah, works again. Now, the next thing we want to do is we want to check whether we opened the file successfully, which is, or rather we want to check whether it wasn't opened successfully. So if not, file dot is open. If that's the case, if it's not open, we want to just return in this case.
With some error code, yeah.
Yeah, exactly.
Good enough for now.
Yeah. So now we have that, the file will be open, and we want to read from it. So I'm just gonna prepare a variable that we can read into, a string, and I'll just call it line. Makes sense in this context. And then I want to std get line, and the stream that we will be specifying is the file. So file, and we want to read into line, and the delimiter is fine as the default delimiter because we want to read the whole line. And I think this should be it now. I just want to print the result of this. So cout line, and yes. No, so we actually had that earlier in the slides. We don't have to close the file. It will close itself because it's of type if stream, and if stream closes itself.
When the object gets destructed, then it closes itself. So we don't have to care about that.
Yep. Okay, so I think this should work. Let's put this to the test. And yes, it prints a cute little kitty. Good. Now, imagine I want to read another file, another line from the file. So what I could do is I could just do that.
So basically,
So,
you have
I just copied the code.
Yeah.
Yeah.
Probably you will do this then in some loop structure if you want to read multiple files, multiple lines. Yeah.
That would be a good idea.
Yeah.
Exactly. Now, if I run this again, this is strange. I don't
know.
Yeah, you don't know, but I'm going to show you why this is strange to me, because in this file there's only one line, and this line is the cat. So what happened here? Does anyone have an idea what happened in this case? No.
So the answer was whether it's always read from the beginning. No, this is not right. So any other ideas?
Yeah.
It failed the second time. There was already the cat in the output string, so it just printed.
Exactly. So the second get line failed, but the second print didn't fail. So we just printed line again.
So
And
the string line was not modified.
exactly.
With the second get line.
Yeah. And the way we can handle this now is we can just write an if around this. It's no magic. And just in the case that it's not, just to get a bit more output, we want to write something like end of file reached. Okay. I think this should work now. Let's just try it out. Yeah, of course.
Yeah.
Yeah, exactly. Now it works. And it was like you said, it is actually because because the get line failed, the second get line failed.
And this is also now the way how to detect whether we reach the end of the file, basically.
Exactly, yeah. I mean, we could also use that as the termination condition for loop. And then just go as long as we want. Yeah, so that's the code we just discussed. And
yeah, basically, that's it so far about files. Are there any further questions regarding this topic? Where was
Possible to read files in online GDB?
Yeah, it is possible. Yeah, you can read files in online GDB as well, but I don't know how to configure it, but it is possible, yeah. I think we also used it in the weekly exercise at some point in Introduction to Structured Programming. Any further questions? Okay, otherwise, thank you a lot for the presentation. I think you did very well. And yeah, we will continue now with the further topics here. Okay, so not last time, but second last time in the lecture, you saw a lot about classes. And we mainly discussed the basics last time, where we created classes, where we talked about attributes, where we talked about methods, where we also talked about the constructor. But what was missing is talking about the destructor, talking about copy constructor, and also dynamic memory was shown. And yeah, we would like to give you a short recap now on these topics. And we start with the destructor. And yeah, when is the destructor called? We said this before in the context of files, when an object is destroyed. So whenever the scope of an object ends or we free it on the heap, then the destructor is called. And yeah, what can be implemented there? Every cleanup that needs to be done. For example, we can free the allocated memory. So if a class allocates memory in the constructor, for example, then it would be a good thing to delete the memory then in the destructor later on. And yeah, basic syntax of the destructor is just like a constructor, but with a tilde in front. And then we have the option to implement something here in the destructor. So I think I also have a short piece of code here for you. Yeah, so I've created such a class lecture hall with a name, with a capacity. Maybe we write short constructor to create it. So this could be, for example, we just pass in a name and a capacity and set it accordingly. And so this would be when the class is created, and now if you use the tilde in front of the constructor, it becomes the destructor. It takes no parameters. And now we can do things here. One example, silly example, would be just to print something here, probably not very useful.
We'll later see some better examples and what the destructor can do.
I don't know if we say capacity is larger 0. There are still people in there. I don't know. But yeah, usually one would free the memory here. And if we test this, if we create a lecture hall with some name, how many people fit in here? I don't know, 350. And if we compile it and run it, then the capacity is larger than 0. And when the object gets destroyed at the end of the main function, then the destructor is called, and in this case, this output is printed here. Okay, so this is simply the destructor, and we will see it then in action as well. What is the copy constructor? Yeah, the copy constructor is always called when we create a new object from an existing object. So yeah, that's what is a copy. Yeah? We create a new object based on an old object. And why was it not so important to care about it at the very beginning? Simply because it is always automatically generated, or at least the basic version of it is always automatically generated, the so-called default copy constructor. And what it simply does, it takes all members that are in the old object and copies them into the new object. And yeah, this is again the syntax. So now this is a constructor, so again no tilde. Then we have a reference to the object that we want to copy, and then we can implement something here. And based on the lecture hall, I can also demonstrate this. So we have a lecture hall. Let's say it takes, as I defined it before, a lecture hall other. So this is the one that we want to copy. We can write an initializer list. So it would make sense if we do a copy that the name should be the same. So we go to the other object. Now we want to access the name of it. And this also works here because we are in the class lecture hall. So we implement this copy constructor in the class lecture hall. And for that reason, we can always access the attributes. So not only of the object where the function is called, but on all objects of type lecture hall. And then we also have a capacity. So we take other capacity and do it like this.
Maybe just for some intuition, why do we need a reference here? Why can't we leave that out?
This would have been my next question, yeah? Why is that?
So why does the copy constructor take a reference to the other object?
Wouldn't this, or I mean, the concept is not so important, this would be enough?
Yes?
If it is not a reference, then it will copy infinitely. Like if there's no reference symbol there, then the parameter will be another copy constructor, and then they will copy each other many, many times.
Yeah. So if there is no reference here, then to call the copy constructor, you would need to copy this other lecture hall into the copy constructor, which would then again need to call the copy constructor. And this would lead to an endless loop. So therefore, we have to have a reference here. And yeah, so that's why it's also like you also need the reference when implementing the copy constructor.
And we usually write the const in front because it's not expected that the object that I want to copy changes during the copying process. seems a bit odd if we create the copy and change the previous object. I mean, it's possible to do that, but probably not intended. And maybe we can also see it in action. Maybe a second lecture hall, which we create with the first one. Probably should always use the same brackets, would make more sense. And now we also have 2 times the message here. There are still people in there because we then also destruct 2 objects, because first the L is created, then the L2 is created, and then the destructors of both are, of course, also called.
And this is not the only way to call the copy constructor. For example, you could also do something like this, and this would also just call the copy constructor. And as we stated before, when you call a function, we know from C that the object you pass to this function is copied into the function, and this of course also calls the copy constructor.
Yeah, we can also test it. So if we have here lecture hall, I don't know, L, we don't do anything, but we simply call my function with the lecture hall L. Then we also see that the destructor is called twice, because this object is destructed, and then afterwards the previous, so the original object is destructed. Okay. And last thing to repeat is dynamic memory. Now in C we had malloc, realloc in free, or maybe calloc as a replacement for malloc. And now we just have only 2 functions anymore, which is new. I cannot highlight it, yeah. Okay. So the new, with the new we just create one object on the heap if you do it like this. So we specify the type, which would be an integer, which should be initialized with 12. So we create an integer object with the value 12 on the heap, and the output of the new operator is then a pointer to this element. So what we expect. We can also create arrays with the new. In this case, we need the square brackets here, and the number in here does not indicate what it should be initialized with, but it indicates how many elements should be in the array. So in this case, we would have an array consisting of 5 elements.
Yeah. So here we just call the constructor of integer with the values we have in here, and down here when we create an array of some variable, then this type needs a constructor that takes no arguments. So integer has that, so you can create an integer without specifying its value. But if you have a different type here, it also needs a constructor with no arguments, because it somehow needs to initialize the array of 5 elements.
Then it basically does not initialize it, more or less, with this operator, so no specific values are stored then in the newly created array. So here really we have the constructor, so a concrete value is contained, and here we have the problem that we just have 5 blank elements that we need to initialize later. And the converse operation is then delete, and it behaves symmetrically. So if we want just to delete one single object, then we call just delete. And if we want to delete an array, we need to call delete with the squared brackets. And we don't need to specify the size anymore. What is kind of missing here is now the option to reallocate memory, so to increase it or decrease it. But you will usually not use the new and delete operator for arrays, because you can simply use the STD vector for that, which is more convenient, and you don't need to think about dynamic memory. There's one natural question that might arise now. What happens if there is no memory? So in C, we were really pedantic about you checking the return values of malloc, whether a new object or the new memory could be allocated. in the dynamic memory in C++, the answer is there is also an option to check that, but we don't know it yet. So for assignment 1, you don't have to check whether you can allocate the memory or not. But I think it will be discussed in the lecture soon, so then you know it. But for assignment 1, it's not important. You don't need to check whether dynamic memory works or did not work. I don't think we need to implement this now. Let's continue.
Okay, so let's continue with the example we already talked about in the beginning, where we'll try to implement a vector for ourselves, which allocates its content on the heap, so we could also resize it. Okay, we'll create a class vector. It will contain 2 member variables. One, the array, which is just a pointer to the heap arrays. We'll just use integers for now. Yeah. Then also the length. We have a typo here, which is just an integer. Yeah, which stores the length, how many elements are in our array. As you know from C, once we malloc something, it's hard to find out how long the memory was we allocated. Therefore, we need to store the length. Then what you also need, of course, is the constructor, which will allocate the memory, and then, very importantly, the destructor to free all the memory we allocated.
So this is a useful implementation of the destructor then. Yeah, I prepared everything for you already.
Mm-hmm.
And in the command line, you need to change the folder.
Okay, so I think you have again 4 spaces.
Yeah, it always resets. I don't know why.
Okay, so what do we need? Well, we want this array. So this will just be a pointer now, not a reference to our array. And then we also want to store the length.
Mm-hmm.
And make this private. And then public. We want the constructor where we want to allocate the memory. Okay, so our constructor should just take the length the vector should have. Something like this. And then we do not take the array because we want to allocate it inside of our vector. Therefore, I'll here, when initializing this array, I mean, I could also do this in the body of the constructor.
Maybe do it first in the body and then move it up.
So I could in here, of course, just say array equals new int of this length. So yeah, that's fine. But I could also do it directly here in the initialization list and try and allocate the memory up here. Of course, later on when we learn how to handle out-of-memory errors, it might be a bit tricky to handle them in here. But if we don't handle them, it's fine. We can just create this array in here. Okay, then we also need the destructor.
So no parameters. And now you want to implement it in the CPP file. So it's a bit longer. Yeah. Maybe. Yeah.
Or maybe. Okay, I'll implement in the CPP file.
For practice, yeah, how to write this. So if it's just a very basic functionality like this constructor, but also like this destructor, it can be always implemented directly in the HPP file.
Okay, so every time now when we create a vector, we allocate memory, and always, no matter in what case, if we return early from the function, if we return somewhere else, if it somehow goes out of scope, we always free the memory. So we somehow can't leak memory right now.
So maybe I can use your vector now and do something funny with it. Okay. I just maybe move the main to this side over. Okay, so I already included your vector. This is really nice. So let's create maybe an instance of the vector. My list. Wrong keyboard layout. My list. And I don't know, I need to specify the length, so maybe 10 objects here. And yeah, let's try whether this works. So I don't know. What do we need to compile? Main CPP and vector.cpp. Let's look at the warnings later. I don't care. And maybe run it. Very nice. Maybe we should also show very briefly well-grinned. So now we use dynamic memory, and how can we see that everything worked out well? So hope you're familiar with well-grinned already from ESP. So we just call well-grinned, and then the executable. It will do memory checks on it, and it states error summary, 0 errors from 0 contexts. Very nice, no memory leaks. This is what we want. Okay, and now it's a vector, right? So my list at 0, I want to initialize it with 350. Yeah, I want to do this. Can you implement this for me, that I can do something like that?
Maybe first I look at the warnings.
The warnings, yeah, this would be a good thing.
Okay, field length will be initialized after field array. Okay, what it tells us here is that we have array defined before length, and then C++ will initialize array first and then length, but I wrote it the other way around in this initialization list, and now it's warning us that we shouldn't rely on the order I wrote here. So an easy fix is just to move the length one line up. So it's the same order as we have in this initialization list. Normally, you would probably swap the order of this initialization list.
Yeah. So one thing just to remember, you have to initialize them in the same way.
Now it tells us that length is not used. Well, we set it here, but never use it. So I hope this will change now. So I want to write a function where we can access the elements in our vector. And maybe I could try writing something like this. Okay, so, right. Something like this.
So basically, I give you an index, and you give me the integer, which is at the position.
Yeah, but right now we get an error here. Expression must be a modifiable L value. This kind of already tells us what the problem is, namely we return an integer here, and we try to set it, but it's not really a variable or something we can set, because the integer is copied out of our array, returned from the function, if I implement it like this, so we can't set it.
So think about, you have a function, return something from the function, and in this return value you want to store something.
Yeah.
This is not possible. Yeah, it's just the other way around possible, where you take the return value of the function and store it in a variable. But now we want to do like the converse.
Yeah, and also what we probably want here is that we actually modify the array. And even if this would work, we would just change the copied integer that we copied out of the array. So what we want to do here is to return a reference to the correct integer in our array. And then we can just assign here. I mean, I didn't implement it yet, but also already we don't have any errors in the main file, because this integer reference is something which we can assign a value to. So let's implement this. We return this integer reference, take this index. Now, what do we want to do? We probably want to check we already have the length, that this index is not out of bounds. So we'll check if index is greater or equal to length. Greater or equal because we start at 0, and if the index is the length, then this would already be 1 too much.
And what if it's negative?
Yeah, we could also check that.
Mm-hmm.
Yeah, this length. So.
Yeah, let's try it. I'm a bit confused about the
Oh,
it should be like the other way around.
I flipped it, yeah. So I think I said the correct thing, hopefully. So I'll just return the integer at this index, and hopefully this will work. So we never return a reference, I think, in these practicals, but let's try. Yeah, we get a warning here because we do not return something if it does not exist. Maybe let's just run it like that. And at least we do not get any error. So this seems to work.
Maybe we can print now my list at 0.
And yeah, this seemed to work.
So really the 350 is now stored in the array using the add function once for writing something into the array and also once for getting, so reading from the array, getting the value from the array in the cout.
And how to handle the case, we have down here, where the index is out of bounds, but we have to return an integer reference, and we don't know what should we return when the index is out of bounds. What to do in this case, you'll hear in today's lecture.
Is it today? Yeah,
Yeah.
It should be today. Yeah, so there is like a mechanism in C++ that how we can handle errors in a better way than we did in C. So in C, we would need to return something here, some fake integer maybe, and check then afterwards if it really worked, but we will see a better way here in C++. Okay, this is now really nice, I think. Maybe I write the function now. Initialize array. I pass in the array. Okay. Initialize array. Okay. Vector reference, because we want to initialize something. Okay. My list, and I don't know, for integer I equals 0, I less than, so we set the length to 10. It would be probably nice to have now a getter for the length to just get the right length of the array, but let's do it very simple. At I equals I. So it should go over the array, initialize everything with the index. Okay, this is nice. And maybe we also write the function, I don't know, print array, my list. Okay. So now let's get rid of the reference here, because I mean we just printed. We don't need to keep the information, so we can just take a copy of my list. Doesn't matter in the printing setting here, and probably just copy the for loop from before. And now maybe call something like this. Then the corresponding element, and then maybe a new line or something. Okay, so we initialize it with 0, 1, 2, 3 until 9. Then we print it. We don't need to see out here anymore. Should work. Wrong programming language. Compile it. Yeah, the non-void function is not so important. Run it. Okay.
It seems to work.
Yeah, it seems to work. So everything is printed fine. But there is something. Double free detected somewhere. Yeah. What could be the problem here? Does anyone have an idea what is the problem here now? But basically my code worked.
Yeah, but now we get the error that we somehow free something twice.
No.
One of those functions, when the parameter goes out of scope, it calls the destructor, so it tries to freeze it, and then when our program ends and the object goes out of scope of main, it tries to free it again, but it's already freed.
Yeah, this is right. So because the myList is now an object in the main function, which contains a pointer to the array on the heap. Now when we initialize the array, we just have here a reference, so we do not copy the vector. So everything is fine. But then when we call the print array function, we make a copy of the list. And we said before the default copy constructor does a very simple thing. It just copies the values of length and array into this newly created object, which is here. And now, blah, 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 we do the printing. And then afterwards, as you said, the destructor is called of myList. And what does the destructor do? It says, okay, I delete the array.
But what is the value of array? So the copy constructor just copied both member variables into the new object. So it just copied the pointer. So it points to the same array as we had before.
And now when we free the pointer once, then it is freed. And if the other vector wants to free it again, it would free it a second time. And this is why we have the double free here.
Okay, but we also have some slides for that.
Yeah.
So what is the problem? Well, we have the default copy constructor, which is automatically generated if we do not implement it. And this copy of this array pointer now points to the same array in the second object that is copied. Then we destruct both objects. The first object works fine, but if we afterwards try to access the array or destruct the second object, we get a double free.
We have a nice visualization of that. So the blue things are the two objects, and both have the error, so the pointer to the same data, which is the array on the heap. Yeah, and if one does something like freeing the data, then also the other cannot access it anymore.
So what is the solution? Well, we implement a copy constructor. Then in this copy constructor, allocate new memory and copy over the whole array. And this is called a deep copy. I think we have a visualization as well, yes. So what we do is allocate a second block of data on the heap with new copy over all of the data, and then each of those two vectors has its own pointer to the heap, its own memory on the heap, and also can free each of those data blocks when they are done and not when the first one of both is done.
Yeah, I want to use my vector now, so please implement it for me.
Okay, so we need a copy constructor, and we said we always take a reference because anything else wouldn't make any sense. And yeah, we want to initialize the length already because we already know that this is the length of the other vector. Yeah, I'll just implement it in here. And what do we want to do now? Well, we do not want, what the default copy constructor does is it sets our array pointer to the array pointer from the other objects. And this is, of course, not what we want, because then we would point to the same location on the heap, which could lead to all sorts of problems. So what we are doing is we set the array vector of the current object, so just array, to some new memory with the correct length, like this. And we are in here in the constructor, then this initialization list is already done, so we can access the length and list the length of the other object. And then we need to copy over all of the data. So we need a for loop. And we'll copy it over.
Okay, and again, here in the copy constructor, we can really take from the other object the private members. We can access them here. Once I did OOP1, I didn't realize this in the beginning. But if you're just in the class vector, you can access the private attributes of all objects of this type, and not only of the object where the method is called on. So not only the newly created vector, but you can really access all vectors here. Okay, yeah, let's maybe try it out. So compile it again. Still the warning from the add method, but we don't know better how. And now run it simply. Yeah, okay. It prints from 0 to 9 all elements, so this is very nice. Now maybe check it also with Valgrind. And also with Valgrind, we see, okay, again, 0 errors, so we did everything fine. And yeah, now we have more allocs and more frees because we needed to create a copy here. Okay, so basically now we can really use our vector here. The copy works, so everything is fine. Maybe some more thoughts to conclude now about the copy constructor. So we said before, whenever you have this kind of problem where you do some dynamic memory allocation or more generally something with pointer in the constructor or inside of the class, you need to think about what to do with the copy constructor.
Yeah, or even more generally, if you need to implement a destructor for any reason, then you also need to think about what happens in the copy constructor.
And one option is that you really implement the copy constructor and not necessarily make a deep copy, but make the right thing here, that you don't run in problems when you copy your objects. There are also other options. One option is that you explicitly delete the copy constructor. This means there is no default copy constructor anymore, and there's simply no copy constructor. No one can copy your object, and of course then this problem cannot occur that you make a copy of it and then have maybe a double free at the end. Now the syntax is basically you write the declaration of the copy constructor and then say equals delete. And then we cannot use it anymore. Maybe let's try it out here as well. If I remove this part of the code, so the whole implementation of the copy constructor, and just write delete here, then this is fine. However, this is not fine anymore because print array would copy my list, which is not allowed anymore. And if we compile it, you would also get an error somewhere here. And it says, yeah, call to deleted constructor of vector, or copy constructor of vector in this case. So this is then not possible anymore, and we cannot run into the problems. So whenever you don't need to copy something, you can basically delete the copy constructor, so you will not run into problems. And once you need it, then the copy constructor later on, you can always implement it. Okay, maybe one more thing. Maybe you can also, not in this case because we see that it doesn't work, but you can also write explicitly default if you want to stick to the default behavior of the copy constructor. So you don't need to implement it on your own, the default one. On the one hand, it's already implemented, but you can also write explicitly default to make it clear.
Yeah, so writing default here is the same as just not writing anything at all about the copy constructor.
But maybe there is something unusual happening in your class, and you say, no, the copy constructor is still fine. You want to make it explicit that you did not forget about implementing it. So, but now let's keep with this implementation. And yeah, as you said before, this rule of thumb, if you have a destructor, then you should think about the copy constructor and either delete it or implement it. Yeah, and later on, I think after Easter, there will be a third operator here important, which will be the assignment operator.
Yeah, because if you think about it, if you write vector 1 equals vector 2, and this is again like the default copy constructor, this will again lead to problems. But no new object is constructed, so the copy constructor is not called. Therefore, we also need to handle this case, but we don't know how to do this yet. So just keep in the back of your mind that if you have a destructor, you need the copy constructor and something else you'll learn later on.
Yeah, so this was the code. As we have a bit more time, we have prepared one more method for the vector. Yeah, so maybe I introduce it now. Now it's very nice that we can access our elements with the add method. We have this problem fixed with copying and destructuring it. But now the vector is so nice because we can increase the size of the array. So maybe there is also the possibility that we call mylist resize and maybe make 20 elements out of it. Maybe you can implement this for me.
Okay, let's try to think about what we need here. Well, we don't need to return anything. Just resize and some new length here. No. Yeah, so I'll also implement this in the CPP file now. Just copy over this function and don't forget to specify that it belongs to the vector class. So what do we want to do now? Well, we want to delete the old array, but before that we want to copy it over into some new array. So we can't call realloc. Therefore, we need to create a new big array, copy everything over, and delete the old one. What we can do now is write something like this, because this would, of course, lead to leaking the dynamic memory of array, because we're overwriting the pointer without freeing it.
And we could also not access the old array later for copying the content to the new array.
So I'll create a variable new array with the new length, and then note that this length is still the old length because we only want to copy over the old integers. So we'll copy those into the new array. Like this. And after we're done with that, we can delete the old array because we copied everything over, and set the old array to the new array. And something else we should not forget is that we also need to update the length to the new length. So yeah, we don't forget how long our vector actually is.
Okay. So we updated the array now. We freed the old one. So memory-wise, this should look good. We copy the content. Yeah, let's maybe try it out. Maybe you can write me a getter for the length. It would be very convenient. Or maybe get length. Okay, very nice. Okay, so now we also have to get length, and maybe we could resize it to 20. Maybe I just copy the initialize and print array function somewhere here and make it now dynamically to be of the correct size by calling mylist.getLength. I need to switch the keyboard layout. So getLength, and also here mylist.getLength. Okay, yeah, maybe give it a try. Okay, it compiled. Maybe directly run it with Valgrind. And yeah, let's see. So now we are printing the values from 0 to 9 because we do this first here. Then we resize it to 20 and then copy from 0 to 19. So now we have 20 elements here. So this is also working very nicely. Now I'm a bit mean, okay? Let's say 20 is too large. Let's say make it 16 and do the same thing again. So now it is very long output. It should print it until 19 and then it should print it until 15. So you compile it. Yeah, nobody cares. And okay, let's see the printing first. So, yeah, we print here until 9. Yeah, this is from before. Then we print until 19. Then we have some weird thing here, and then we print until 15. And it also says we have 4 errors. So I don't have an idea what is wrong. Maybe you can see in the Valgrind file why we're making the mistake.
Okay, let's check. So we have an invalid write in our resize function,
And maybe we
but
can.
we do not have any lines.
So -g, yeah.
Let's check again. Still okay. In the resize line 23, this is where we actually update our array. And what happens here is, well, we passed in a smaller number than before. So, and here we iterate until the old length. And the old length is 20, the new length is 16. Here we are writing into this new array outside of its bound. So now we can think about what do we want to do if we want to shrink the array. And well, let's just not copy over those elements that are outside of the new range. So I need an additional check here that the I is also smaller than the new length, because we do not want to write out of bounds in this new array here, and also we don't want to write out of bounds of the old array. So yeah, we access both arrays. We need to check if I is smaller than the length of both arrays. Let's try this again. And yeah, I think it seems to work now.
Yeah, on the very bottom we also have 0 errors. So yeah, this is really nice. Okay, do we have anything further, or I think this is something very unusual, but today we finish 5 minutes earlier. I think this did not happen very often the last 5 years in the practicals.
Yeah, but maybe before we go to the summary, yeah, as always, the code is in the slides if you want to look it up afterwards. Are there any questions to any topics we did today? Yes? Okay, so is the output writing to files relevant? No, not for the first assignment. It's very similar to writing to std out. But maybe we'll show this in a later practical session.
And it will be certainly covered in some of the lecture units, but we don't need it for assignment 1, so we haven't discussed it so far. Yeah?
Is making a pointer that points to uninitialized parts of memory also considered a memory error for this first task?
Is making a pointer which points to uninitialized memory error?
Yeah, yes, because for example, when we made arrays in ESP, we were encouraged to use calc so that it would initialize all the elements of the array to 0. So do we have to do this here manually by just writing a function that goes for the elements and put some value in there, or is there a way to initialize it when the pointer is just like in C?
I mean, you can call some functions which does it for you to initialize your memory, which you just allocated, but of course, as in C, you don't need to do this. You don't need to initialize everything to 0. Only if you read from the memory which you did not initialize, then it's an error. But if you have something like a vector, oh wait, no, I think, yeah, if you do new like this, then actually the memory is always initialized.
So if the
yeah,
new on a single object is always initialized, new on an array is not necessarily initialized. You don't need to do it, but of course, if you want to read from it, it must be initialized first. So basically, if we...
Even I said this before, if you call new with the square brackets and the size, then you need this default constructor because this is called for every element in the array. So you can't have uninitialized memory.
So if I do something like removing this part here, removing the initialization here, so just by list, get rid of this. In this case, we would just call the copy constructor. The copy constructor just call the square brackets here. And if we print it now, it's not initialized. And we will see this here as well. If I run it with Valgrind, then we have 40 errors, and we have these conditional jump or move depends on uninitialized values. So we have uninitialized values now, so you can't use it. You will get memory errors if you use it, but if you first initialize it and then use it, it's no problem. But you don't need to do it immediately. Yeah.
Right, because the default constructor for integer does not initialize it.
Exactly.
Yeah? Okay.
Any further questions?
Okay, maybe just to clear this up because this was a bit confusing right now. If
Okay.
you do new something and then the square brackets with the length, it will call the default constructor for each of those elements. So if you have some maybe recipe class that we wrote last time here, then it would call the constructor with no arguments for every element, and you would not get these uninitialized value errors.
So
but the integer constructor with no arguments does not initialize the integer as in C, and now you get those uninitialized errors.
So basically it depends on the implementation of the default constructor. So if it's not implemented, then it will not initialize it. But if there is some implementation that initializes the values, then you don't have uninitialized values there.
Yeah.
So, sorry, just to make it clear, so I'm asking this because in ESP, Valgrind would treat uninitialized variables or elements of an array as memory errors, not mistakes. So if I do not implement in the constructor for loop which will initialize my array to some value, it won't initialize it in case of init, because its default constructor does not initialize values.
Yes, so if you do not initialize these integers, the integer constructor won't initialize the integer, so we will have uninitialized values here. But if we never read those values, everything is fine. Only when we try to print them, then we'll get an error. So as long as you do not read uninitialized values, you won't get any errors.
Okay, any further questions? Yeah, otherwise you can always ask in a few minutes down here. So what have we seen today? Files and input in C++, which Elias did for us. And that's everything you need for assignment 1 regarding these topics. And yeah, we also discussed the destructor, copy constructor, and dynamic memory with the heap array, where you hopefully now have an idea how the std vector implementation works. We did it rather similar to the standard vector, but of course we kept it very basic. The standard vector can do much more things. Yeah, okay, then maybe in 10 minutes. Yeah, so at 5:25 the lecture will start. And
yeah, maybe next time we can show you with the dynamic memory how the constructor is called, so you so you might understand this better.
And next time we have 2 hours of practicals, and there will
Yes.
not be a lecture. 2 hours of practicals, 2 hours of us. Thank you.